Hi, and welcome to another interview for the 0 to ASIC YouTube channel. And today I'm very pleased to be joined by Staf Verhaegen. How are you doing, Staf?
I'm doing fine.
Great. So people may know you from your Chips4Makers website or Twitter handle, but could you give us a bit about you and your background?
Yeah, so uh, my professional career, I've been working for almost 25 years at IMEC, which is a big microelectronics research institute. I've been there in the TCAD group on doing data mining on FAB data. Then I went to lithography, where I was working on laser resolution enhancement techniques. And then my final job was working on standard cell and I/O libraries for radiation hardened designs. And in that respect, I also came into contact with the Euro practice part of IMEC, which makes MPWs for SMEs and for the academics in Europe. And there I saw that actually for mature nodes, the silicon cost is not that big, but that the cost for the EDA tools is very high compared to the silicon cost. As a hobby, I've also been doing open source programming. One of the things I've done was Eros, which is an open source implementation of the Amiga OS. So I'm also in the retro world. To combine these two, I saw that open source as a good way for reducing the cost of the EDA tools. And that's why I quit my job 2 years ago to work on open source EDA and all the tool flow in microelectronics. And then my target is to be able to make chips possible for normal people, for makers, I call it. And that's why the name
Hence your moniker,
Chips4Makers.
Chips4Makers. Yeah. So could you give us a price point? Because you're saying that the silicon isn't that expensive, but just so that we get an idea of the kind of numbers you're talking about.
Yeah, so an MPW on 0.35 technology cost less than $5,000. But I made a quote for what I found not a. I asked for a quote for doing the placer route for what I thought not so difficult project, and then they said yeah, it was 30,000 euros, above 30,000 euros to do that. So, and then my plan is to actually even try to share this cost of $5,000 between, let's say, 4 people. And then my target is to be able to make chips below 2,000 euros. So that's my target.
Cool. So that 5,000 is one of a number of MPW slots. So then Euro practice joins together all these projects together to divide up the mass costs.
Yeah. So currently, yeah, IMEC is a partner or as a preferred partner for TSMC, and they do, I think, 5 or 6 times a year than this 0.35 TSMC run. That has a minimum area of 25 square millimeter. And what I plan to do is then to subdivide this 25 square millimeter, and I will do the joining of the project.
A bit like my multi-project tools.
Yes, what you're doing for Sky 130 multi-project tools.
Okay, cool.
Yeah.
Okay, so I've been wanting to interview you for a little while, but you've been super busy doing a tape out recently. So could you tell us a bit about what you've been working on?
Yeah, so Sunday night or Monday morning, I taped out a 0.35 TSMC MPW, and that was the retro microcontroller. I already, when I quit my job 2 years ago, I actually made some presentations at ORConf and also at FOSDEM about what I wanted to do, and I now finally could make a first tape out. And the thing is to show that with these old technologies, you cannot do the very advanced things. You cannot make an advanced GPU or advanced mobile processor, but we can still do more stuff in retro type performance or better. And then the retro microcontroller is where I combine a Motorola 68000, a MOS 6502, and a Z80 on a chip. And actually, I split it up in two chips. One chip has a Motorola 68000 and MOS 6502, and the other chip has a Z80 and the MOS 6502. So the one contains 32-bit, the other one is pure 8-bit. And I wanted to have two designs so that hopefully Murphy allows me that I have one of them working. Yeah.
So where can people find out more about that project?
This project itself is, I distribute all my code, which I can make public on GitLab under the Chips4Makers thing. So there is a retro microcontroller project there that contains this code. Of course, I'm using a proprietary PDK, and that I cannot make public, of course. But my idea is to be able to also support open source, and then everything can be open sourced, like Sky 130.
And what's the tool flow that you're using? Because I'm guessing that you're not using OpenLane.
No, I'm not using OpenLane. So when I quit my job 2 years ago, I did an evaluation of existing tools at that moment. And then OpenRoad was still in the early phase of development. And I actually then also found Coriolis, which is also a place around tool developed at Sorbonne University, the Lib6 department there. It's already being developed for 20 years there. And I find it a hidden gem because I think they have done quite some development work, but they were not that good in the marketing department, so it's not known. And also, it has a quite steep learning curve. So once you start doing it, then you will need to do a lot of perseverance, or how it's called in English, yes, to get used to it. But I found the foundations better at that time at OpenRoad, and then once you choose, you don't switch anymore afterwards. And then around that, I like Python a lot, so I'm using MeGen. That is now still called MeGen, but that's going to change names in the near future, I think. The open source cores I found was from some retro projects. They were still written in VHDL and Verilog, but I have then a wrapper around that in NMeGen, and the top of my retro microcontroller is developed in NMeGen. Then I use Yosys for synthesis, and then I still use K-layout and API to do some post-processing on the GDS generated by Coriolis for place and route. Yeah.
Great. Okay, and if you want to find out a lot more about Coriolis, then you can check out the talk that Jean-Paul Chaput did for Open Tapeout at the beginning of November, and I'll put a link in the description to take you there. Okay, so one of the questions I've got for you is about standard cells. Can you guess what my question is?
I think we can suppose that people are familiar with now a little bit with EDA flow, but standard cells are actually the basic digital building blocks that you make up a digital design from. And it's one of the basic building blocks that you need to make your design.
And they normally come from the foundry, don't they? So you get like the AND, the OR, the flip-flop, the XOR, all these types of standard cells as a package from the foundry.
They come from the foundry or from IP providers. For example, ARM also has a standard cell library, Synopsys, the big EDA vendors also have their standard cell. But I did my own standard cell library because one of my targets is to be able to support different technologies easily. And there I found the current existing, also the open source one, too much work involved to port it to new technologies. And I do that based on a Python framework I developed that should allow making these standard cells scalable more easily. That framework is called PDK Master. Yeah.
Okay, so the framework is called PDK master, and then the thing that generates the standard cell, is that called flex
Yeah, so
cell?
it's Chips4Makers flex cells. So it's on the
Okay.
website I also already mentioned is C4M dash flex cell. Yes.
Okay, we'll put a link in
Yeah.
for that. So, and then is it right that you take the DRC rules from the PDK and that's like the input into FlexCell, and then FlexCell generates standard cells that are DRC safe?
Yes. So that's the task of PDK master. So in PDK master you describe the technology, and then the design was a part of the technology. So the technology is which devices are available, transistors, diodes, and other things. Plus then the rules that are coming from that to be able to manufacture them, and that's called the design rules. So what I wanted to do there, and what I did, is that you can describe this technology in one file, and then from this one file, all the files needed for other tools are generated from that one. And there is an API so that you can build on top of this technology description scalable circuits where you can do combined layout and circuit generation, because often now the layout generation is done after that you have done the schematic, and then that's also a laborious task at the moment, and I want to reduce there also the effort you need there.
Okay, and actually we saw in MPW3, the Google sponsored free shuttle, Myrtle Gatecat Shah just taped out a design using standard cells generated by FlexCell for Skywater 130.
Exactly. So that's one of my next tasks, is to get that stable so it can make a public release, because I still had to hack a little bit around in my Python code to get it DRC clean for the submission. But in the next MP4 run, which is end of this year, exactly, we will be doing new designs, and then I think it should be available for other people also.
Okay, and how does the standard cells compare in size compared to the ones that we get from Skywater? Are they the same size? Are they a bit bigger, a bit smaller?
Currently, they are not area efficient yet, because what I did, I took a shortcut and I took an existing standard cell library that was based on lambda rules. So that was also made scalable. So the old way to do scalable is that you describe everything as a function of a certain lambda, and then you can change by picking your lambda according to your technology. But these,
and then everything scales
yes,
linearly.
then you have to be sure that all your design rules are described as a multiple of this lambda, and then you don't squeeze out the last area efficiency. But one of the tasks that I'm starting now is, and should be done at the end of this year, is to have a more efficient, and then it should be comparable to any standard cell library. If we really want to support the really high density ones, which is called the HS version of Sky 130, that's to be seen, that's to be looked at, because often you need so much overhead in empty space to get the routing done that it doesn't make sense to make these very high density standard cell libraries. But it's something that we will look at.
Okay, so maybe you could tell us about any other projects you've got going on at the moment?
Yes, so a lot of this is funded by NLNet and project, actually European projects. So you have now NLNet, but you also have NGI Ponter, which is done by another entity. So I've been also involved in the LibreSoc tape out, where we also use the standard cell library in 4.18 TSMC, and actually also an I/O cell there. So I'm involved there. So they also are planning a new design in October of next year, where they will do an Ethernet router, and I will then also be involved in getting the technology part ready for that. And there I will be doing I/O cell development and memory development also. And the first thing to do is Sky 130 support. Part of that is also, and then another project is to have scalable analog mixed signal libraries. So that's together with the Leipzig University. We are looking at first very simple analog mixed signal, so a simple ADC, a low-speed ADC, DAC, a PLL, and a band gap. So I wanted to stick to simple so that you can focus on the technology and the development part, and you don't need to squeeze out the last analog performance. But there I also want to use my PDK master to make easily scalable analog mixed signal libraries. There Leipzig will look at what schematics and circuits can we use that are easily scalable with technologies, and then I will be doing the implementation on top of PDK master to make them scalable to different technology nodes. And the first task I will do there is to work on PDK master version 1.0, because now the API is not fixed, and it's probably very frustrating if other people want to use it, because I will constantly making non-backwards compatible changes to the code. But the plan is to have beginning of next year a version 1.1, and that then should be ready for outside contribution and usage. Yeah.
Okay. I'm not totally sure I understand what PDK master is now that you've said that. So could you give me like a top level overview of the job you're trying to solve with that?
So yeah, there are, I think 3 things that I wanted to do is, first, I'm a Python guy. I don't like Tcl, so I first wanted a framework that is in Python and not in Tcl or any other language. The second is that I wanted to simplify the description of the PDK itself. So I don't know if people are used to PDKs, but often a PDK is delivered as a bunch of files that you have to know how to use them and to configure the tools to use them. So I want to simplify that. And the last one is that with this simplified description, you could put generation of circuits with their layout on top of it that can easily be scaled. So you make a new description of technology, and then your code that generates these cells should adapt to the new technology, and the API should make it possible so that you don't need to make changes to your code to be able to scale to different technology nodes. And that's what I want to apply to the analog part in that project.
Okay. So is it like a kind of standardized API to a PDK?
Yes. You can describe it that way, yes.
Okay. That makes sense. And then just going back to the analog stuff, scalable analog stuff has been tried quite a few times in the past, I believe.
Yes.
Or things like analog generators. Yeah. So what makes yours different, or why try it again?
Yeah. So first thing is analog designers are typically working the first thing they ask is, give me the specs, and then I can design an analog circuit to you. And so that's a design to spec. But that means that every time you change a spec, that you have to redo the design. So what I wanted to do is look at it from a different side. Is you have a technology, you have a certain schematic of the circuit. What can you do with that? And then present to the user what he can do with that. So in that way, that's the first thing I want to solve in the analog part. The second part is that often the design is done on schematic level, and then they try to do the layout. So the automatations that are now doing is actually starting from a schematic or a netlist, and then try to automatically generate a layout out of it. And I don't find that ideal yet, because especially for lower nodes, the interconnects, so what they call the parasitics, your capacitance and resistances of your interconnects become important. And then you have to do iteration loops because, you made the schematic, but once you have done the layout, it doesn't perform the same anymore, and you get a lot of iterations. So what I want to do is to have that you have code that generates both the schematic and the layout, so that you do both at the same time, so that you have a better performing circuit from the start, and in that way you should be able to be scalable. And one thing is also I want to do is not squeeze out the last performance of your technology. So when you try to do that, then you still need probably more the classic way of doing design, so that you really optimize your circuit to really squeeze out the last performance. For example, a high-speed SerDes, I don't see that being done with this scalable analog framework.
But maybe like a straightforward A to D or D to A.
Yes, and maybe not that straightforward. It's just that if you don't squeeze out a 10, 20% performance of your technology, I think that should be possible.
Okay, and then the idea is if that's still useful, then that saves you a lot of time and effort.
Yes. Yes, and you can still you can still take then what comes out of it, and if you really want to squeeze out, then you can still optimize it afterwards. But then it's not scalable anymore, but that's still a possibility.
Okay. And just to finish off then, I'd like to hear your opinions about the future of the industry, because you've got a lot of experience, a lot more than I do. We've seen a bit of a shift in the last couple of years with a lot more stuff becoming open source and a lot more people getting involved. Do you think that is something? Are we seeing an inflection point here? Do you think the industry is about to change, or do you think it's going to? What's your viewpoint on that?
Yes, I think the industry is definitely going to change in that respect. I see a lot of parallel of what has been happening in the Linux world, mid-90s. So, so like I said, I've been working 25 years at IMEC, so we were using Unix at that time. So I saw the start of the Linux at that time also. And then in the beginning, it was something that when you were a professional, then you were using Unix and not Linux. And at a certain point, I even saw that I talked with developers of EDA tools at the commercial companies and said, internally we're already using Linux, but from marketing point of view, we still only sell our tools for Unix because our marketing does not want to promote our tools yet for Linux. And if you now look 20 years later, you see that Linux has disrupted the whole industry. Everybody's now using Linux, and Unix is not, it's very minor at the moment. And I think the same will happen for the EDA companies, for the EDA tools, and then the whole microelectronics industry. And I think we are really seeing now with all what's going on with Google sponsoring the MPWs, with the conferences, with your channel, that we are really at the tipping point to starting this revolution for the EDA world, yes.
And you see this kind of starting in the kind of lower end, older nodes, and perhaps like the places where you don't need to get like what you were saying, squeeze all the performance possible, but where you still have an advantage with making a custom chip as opposed to something more generic like an FPGA.
Yes, indeed. So I'm thinking more about the mature nodes, lower volume. That's the place where it will start. And because if you go to high volume and small nodes, the money involved there is so big. So a master there costs millions of dollars. So if you then have to pay $100K for your EDA software, that's not a showstopper. But like I said, for low volume, more mature nodes, the EDA software is very high, and I see there then where it will start. Yes.
Great, interesting time to be involved.
Yes, I'm enjoying myself.
Your time has come, Staf. Great. So where can people get in touch with you if they want to learn more about you or your projects?
So I have a website, Chips4Makers.io /blog. There is a blog. And I think if you mail to blog@fibraservi.eu, you will be able to reach me. I think that's the best way to reach me. So
Okay, we'll put the links for that in the description. Okay, well, thanks a lot, Staf, for your time. Been really good talking to you and great to hear your thoughts on what's going on.
Okay, good. All right.